Good morning. Today we are going to do a lesson on polyatomic ions. This is going to be a two-part video lesson. The account I have for YouTube won't let me post anything larger than 15 minutes, and we need to go slightly above that today. As always, you can pause your computer at any time to catch up with the notes. All right, so polyatomic ions, here we go. What is a polyatomic ion? Break the word down. Poly. Poly means what? More than one. And atomic means atom. So polyatomic ions are ions that are made up of more than one atom. All right. So everything that we've worked with in the past 2 weeks has been what we call a monoatomic or monatomic ion. And mono means one. So everything that we've worked with has been made of one atom, and today we're going to change that. So let's compare and contrast the differences. So on one side, we'll have monatomic, and on the other side, we will have polyatomic. All right, if you need to pause at any time, go ahead. All right, so monatomic, the prefix mono, we said, meant one. And we know it had one atom because it had one capital letter. So everything we worked with only had one capital letter. When you wrote the formula, then it had two, but up until this point, everything had one cap. A polyatomic ion is more than one. So how do you know if it's more than one? Well, there'll be two capitals or more, or there'll be one capital and a number. So very similar to writing compounds. So what we've done is we've used monoatomic. So this is how polys are different, or how are they the same, how are they different? Throw in a little bit more vocab. Monoatomics, when we wrote them, the first one that we wrote was the positive ion, or the cation. And a cation is a positive ion. So a few cations that we had ones that were +1, like lithium. We had ones that were 2+, like magnesium. We had some that were 3+, like aluminum. Now, their charge is more than one, but there's one capital letter, and that's what makes these monatomic cations. The second ion that gets written is our anion. And anions are your negative ions. So we have something like F-, O2-, N3-. So yeah, their charges might be more than one, but there's one capital letter. Something else that these anions all had in common last week is that they all ended in "-ide", fluoride, oxide, nitride, phosphide, bromide. So they all ended in IDE. So we have monoatomic cations, we have monoatomic anions. I might do a vocab review with you guys this week to help you kind of get down and nail down some of those vocab words. All right. So polyatomic ions, here's where you are going to have to open up another tab. If you go to our classroom page and you look at the materials for this week, the materials for this week include a doc that says polyatomic ion. And so I have that doc open here on this page. What I would suggest you do is pause the video now and find this doc. All right, once you've found this doc, maybe bookmark it. Maybe if you have a printer, maybe print it out. You can always take your cell phone and right now, take a picture of the chart. Make sure you get the whole chart. Because you can use this chart on any test, on any quiz that we're going to have on this material. This chart is the closest one that I found to the one that I would have handed you in class. All right, so for our polyatomics, if you look through the chart, one, you can see that, yeah, it has a title. It says polyatomic ion. These are the common ones. So if you were to look in ingredients or, the things that make up, like your shampoos, your body washes, like the everyday household items like cleaning products, this is where you're going to see a lot of these polyatomic ions pop up. What I like about this chart is that this chart is organized by charge. So everything in this column right here has a charge of 1 minus. And note, they're polys because they have more than one. All right, so the first one we have on our list is dihydrogen phosphate. Well, it has 2 hydrogens, 1 phosphorus, 4 oxygen, so more than 1 poly. Everything in this column right here is 2 minus, and everything right here is 3 minus. So all of these are negative ions. They're anions. There's only one cation that we are going to use, and that cation is ammonium. Okay, so like pretty common in cleaning products. So hopefully you found this chart. Please keep it out throughout this lesson. It's in the material, it's in this week, and it's posted as a material. So print it, bookmark it, take a picture of it with your cell phone. Okay. All right. So I'm going to flip-flop between this tab and the Zeitboard tab for the remainder of today's lesson. So let's talk about and compare what we have with our monos with our polys. Okay. So we said that we had cations, or positive ions. And there was only one cation listed on that chart. Okay, that chart, the cation for this is right here. All right, our ammonium. So for our cation, the only one we have, there's only one, it's NH4, and its charge is 1 plus. Or anions. There are so many anions on that chart. Basically, everything else is an anion. So an anion could be nitrate, NO3, 1 minus. It could be sulfate, SO4, 2 minus. Could be phosphate or phosphite, PO4, 3 minus. And these are all polys because you see I'm writing more than one capital letter and I'm writing some numbers with them too. A difference between a monoatomic anion and a polyatomic anion are the endings. These guys end in ate. They end in ite. And they also end in I'd. So their endings are a little bit different. Now, when we talk about a polyatomic ion, let's talk about phosphate. Phosphate is PO4, 3 minus. This right here is the phosphate polyatomic ion. That does not change. You can never change the subscripts in a polyatomic ion. Right? So you can't change these. Don't do it. Because then you change the ion. If we go back and if we look at this chart right here, you can see that here we have something ending in ite and ate, nitrite, nitrate. The only difference between the two is one oxygen. So we talked about, if you add an oxygen to water, water becomes peroxide. So it becomes something inherently different with different chemical properties. So the rule going forward is you can't change the number on a polyatomic ion. And I will demo that in our next lesson.